Ben, c'est parce qu'on live stream. Mais fait pas pour vous autres. Ils n'ont pas eu le temps de se taper le son, les gars. Là. Ils sont dans le jus. Ah ouais. Ah, j'ai mis ça sur YouTube. Ouais. Testing 1, 2. Yeah, yeah. Ouais, bah c'est normal. Mon terminal, devrais-tu me zoomer? Ah, c'est bon. C'est on commence à l'heure.
C'est un gros buffer ici.
Ouais, il n'y a rien avant le temps. Mais moi, Geneviève, elle m'a dit par exemple qu'elle allait faire installer des haut-parleurs, ça me marchait d'effectivement. Ça va comme nous, peut-être me dépêcher. Fait que là, allez tout. For the 0% on the stream, you should go on ctf101.northsec.io and make sure to create an account. And then I'll talk with the people in the audience. Be back. Be right back. I'm sorry, I'm not looking at you. I'm gonna actually just stop this thing and then share my screen. This should be good. All right. Is there anyone who speaks English only? Tout francophone? Parfait. Donc, incite à créer un compte sur ctf101.northsec.io. La façon que je procède actuellement, c'est qu'il n'y a pas vraiment de temps pour que vous. On travaille comme en parallèle. Si vous êtes meilleur que moi, vous faites des points plus vite que moi, vous n'avez pas besoin d'être ici à la fin de vous en rendre compte. Non, j'avais peut-être, puis pourquoi je suis là. Mais pour de vrai, l'idée, c'est de t'apprendre. Moi, je donne beaucoup de théorie comme ça. Mettons, je vais passer comme beaucoup trop de temps sur le SSH. Pivoter des tunnels SSH, pour moi, c'est quelque chose qui est quand même assez important en pentest dans les opérations. Donc, c'est un conflit. À NorthSec, c'est un CPF d'infrastructure. Vous êtes dans un réseau complexe. Souvent, pour les XSS, il faut avoir une machine qu'on contrôle qui fait partie du firewall, etc. Donc, c'est quand même un volet important. C'est assez de la base. On peut pas prendre le temps là-dessus. Mais là, si un moment donné, mais bon, là, on est en 6, 7, on est 5. Si à un moment donné, je vois qu'il y a 5 sols, ben là, on va passer à l'autre papier. Puis, c'est très intime. C'est vraiment mon plus intime, c'est F101. Je vais donner ça devant pas mal de monde. Vous voyez ça comme un avantage. Ça veut dire qu'on va faire ça en gang. Fait que là, le CPF 101, le site, vous n'êtes même pas obligé de mettre un vrai email, de mettre n'importe quoi. L'email n'est pas validé, on s'en donne. Faites tout un compte, là, vous allez pouvoir commencer à faire les challenges. Là, le système de CPF, les classes, je ne sais pas comment, mais ils sont comme un peu à l'envers dans l'autre que je vais les faire. On commence par la track 6 admin en bas. Puis on va monter notre way up dans les prochaines heures. Fait que là, si on regarde ça. Register and work on the challenge. Là, on va mettre mon handle. And oh no, that's login. I need to register. Oh yeah, that's all right. So as I was telling in the room, we're gonna start from the bottom, from sysadmin, and then work our way up: sysadmin, web, forensic, reverse engineering. Unfortunately, I have no way to know if there's anyone online, so I might forget about you completely. At which case, you should have come on site. I'm sorry about that in advance. Okay, so we're gonna look at SSH first. Um, the the way that we're gonna connect with SSH is using a key. So is everyone here familiar with SSH, or have you never heard about it? Familiar? So SSH is basically like remote desktop, but for a console, and it's usually to administer Linux systems. But it is very useful as well because it can carry arbitrary data across a tunnel. We're not gonna do the tunnel part yet, but SSH has an important concept. So instead of relying on passwords, you can use keys. And as an administrator, using keys is very key. But it's the fact that you're pretty much guaranteed the complexity of what the user uses to authenticate. And we're talking like 150, 60 bit of complexity. Again, depending on the specific cryptography used, but it is stronger-ish security. So this is very simple, right? You have the host name, you have the port, you have the username, and then everything is laid out at the bottom for you. So we'll try to connect and see what this leads us to. So if I use this, now you can use Windows subsystem for Linux. It has SSH now, so you can use that. But you can also use PuTTY. So we put in here the key in the PuTTY format. PuTTY is a very well-known Windows SSH client. But for the demonstration, I'm gonna use SSH from Linux. So what we can see, I'm gonna just remove the trust that I established before. Known hosts. This is a bit, whoops. Yeah, all right. It's because I tested all my challenges yesterday, so that's why I had different behavior. I'm also gonna go in this folder and I'm gonna remove everything to show you that I'm not cheating. So we're empty, a clean slate. Now we're trying to SSH there. It's the first time we connect. So SSH is considered a trust on first use protocol, which means that there is some, like the host key is exchanged on the first time. So you could be man in the middle the first time you connect to an unknown SSH server. But after you did the first trust, usually, you just set up the server, so you connect to it right away after. But so once this first trust is established, then if anything in the cryptography changes afterwards, you'll get a big ass warning, really scary, that says you are being attacked. Something eavesdropped in the middle. The secret that you exchange on the first use is different. So now, for our purposes, in a CTF context, you basically are trying to attack the system. So you will trust that whatever key. But then here, what we have is that we're asked for a password. So we know that there is a key pair that was given. So now let's try to use that. So we'll download it. So you start a CTF, you create a folder with the name of the CTF, and then you put your stuff at the right spots. So I have the track is called sysadmin. I'll put the key pair there. And then let's look at the options. I want to pass a key. All right, so we have here identity file, right? Select a file from which the identity private key for public key authentication is read. So we're gonna try that. It's a bit directed, right? So I'm cheating a little bit here. So we're gonna pass -i and then a link to the key SSH key pair. Gonna try to connect. Oh, I'm getting an error, like unprotected private key. Well, SSH is trying to teach you how to do the things correctly, right? It says, you know, this stuff shouldn't be readable by others. So it's saying that the permissions are too broad. And on Linux, by default, other have read access to your files, and they don't know that this is a single user system, so they're giving me this warning. So we're gonna change permission on it. So permission, again, you know, this is CTF 101. We're gonna change permissions, and it's part of the challenge. You know, it's all good. So we're gonna use change mod, and I like the symbolic way of changing permission. Do we see the bottom? Yeah. I like the symbolic. I could. I'll pump it up. Oh, I can't actually. I'll clear. All right. So I like the symbolic way of changing permission because it's super easy to remember as opposed to the octal like 0644 or 777. So the friendly way, you basically have U for user, J for group, and O for others, which is the permission system that you see here, right? So the first sequence of 3 is user, second sequence of 3 is group, and the last is others, or some people call it world. So what the error message I got is that permissions were too broad, it was too permissive. So we're gonna get rid of those readable portion for group and other. Now, with the symbolic way, this is accomplished by saying user must be equals to read write, comma, group and others equal nothing. As simple as that. Don't need to remember the octal stuff. And then I always forget I didn't get into the directory. So and then the file name. So what happens that we remove the read bits by saying that we want nothing in for group or other. Now, will it complain? No, we got in. We were in the system. We ls, you know, we list the files, and there is a flag. Let's look at it. Flag.txt. Learning to use SSH and SSH keys is a very important skills. And we got the flag right there. I'm gonna try it. All right, we got it. So let's check how we're doing. Okay. So anyone so we're gonna move on to the next one, but anyone has questions, or you guys are not set up properly, or this is just too easy, you haven't attempted? C'est bruyant. Il n'y aura rien à faire, la salle est haute. Non, mais je peux parler, je peux aller en avant. Fait que là, tu sais, la difficulté, en fait, c'est premièrement, ensuite, le IP file, le downloader, le français, c'est comme ça. Ça permet de trouver les gros permissibles. La plupart des downloads pour la plupart des systèmes d'application, on rentre avec ces gros permissibles pour temps. Là, c'est tout français comment faire dans les commandes. Parce que bon, c'est comme ça que pas mal de monde travaille dans le fond. Là, surtout en CTF, quand tu es sur un autre de commande, faire gratuitement, c'est facile quand c'est ça. Ça t'aide pas quand tu es attaqué. D'avoir un développement pratique. C'est vraiment bon d'apprendre en ligne de commande. Ça, c'est bon, là, tu es en fait des Écoute, pendant que vous faites celui-là, je vais parler des tunnels espaces. Je vais essayer d'en parler un petit peu longtemps, je ne sais pas en dessin. essayer de faire ici. Donc, les... All right. So, yeah, so I'm going to look at the challenge first, right? Because we need to have a goal-oriented. Resolve, it's good. Okay, so SSH tunnel. It's a very important skill to understand. So you're gonna leverage the machine that you just gain access to in order to reach another machine behind that machine. This other machine is not available on the internet. And this is what's written here is that you could try to reach that other machine from the first one. So the goal is to query a service on the sysadmin service machine. Okay, I'm gonna do a little diagram here. So so this is pivot box, and the machine behind is sysadmin service. Okay, this is the internet, and this is us. All right. So what we did in the previous exercise is access pivot box. Okay. Now what we are asked is there is a service running here. So a process running here on port 5555. What we are asked is to query that service. Okay. But the problem is that so the host name is called sysadmin service. We're gonna try from my computer. We're gonna try to access it, right? But this is not an internet. This is not a global IP address. This is not something that is reachable from my computer right now. Okay, well, what about from the server we just got access to? So from pivot box, can we access that system? So let's try to ping it. Oh, I can't. There's no ping is not installed. Ping is not installed. Can we resolve it? We don't have an SLOOKUP. Okay. Can we, is there dig, another DNS tool? No. Is there systemd resolve? No. So basically, I don't know how from that system. It's a very restricted system, and it's part of the challenge. Okay. This is why we have to learn about SSH tunnels. So again, back to our little diagram here. So we did SSH into pivot box. Ça va? Tu t'es dedans? All right. So we did SSH into pivot box, but there is nothing here that gives us the power to reach the port 555 that we need to reach on this other system. We're not even sure that system exists because we have no tools to query DNS that I found. Does anyone here know another DNS resolving tool that I haven't tried? Host file, the host file. Let's take a look at the host file. That's a good point. So host file on Linux is etc host. Oh, it's there. All right, so we know the IP. That's good. We made progress. So now is there, okay, so we have, so the host file, I didn't even know Docker worked that way. So Docker did inject the IP in the host file. So we know now that this is on a different subnet. It's not an internet accessible address, right? We're gonna put that in our diagram here. Up, that's the IP of this system. And since it's not an internet accessible address, we need to find a way to query it. We need to find a way, but we are in PivotBox. So here we probably have an IP in this subnet. So I try to look at our IP. It says command not found. I'll try ifconfig, command not found. Is there a way I can find my own IP in that subnet? Is it in etc host? It's not. So there's probably a couple ways, and one of the things is we have access to Python, right? So we could put Python code to figure out what's my IP, or what are all my IPs, because Python is basically, you know, an interpreter of a lot of things. But we're not go there because it's kind of out of scope a little bit, but still an important part of the mindset, right? Of the what do you have at hand that can help you solve the problem, which is I need to query that service. So we're gonna forget what's our IP. We're gonna assume that we can connect to this IP. So we're gonna try maybe, you know, so so netcat doesn't exist, curl doesn't exist. So NC is basically low level TCP. It's called the TCP Swiss Army knife. So it allows you to connect, you know, to any IP and port. It's very useful tool for port exploration and stuff like that, but very manual. It's very low level. Curl is for querying HTTP stuff, and it's not there. And then there's wget. Wget is another, it's curl like. So we can see, okay, can we connect to the host? And so by default, it will try port 80 for HTTP stuff, and it says connection refused, but we know that it was on port 5555. So we can do that, and then says connection refused. Okay, now we tried all our options to leverage PivotBox. So we were here, right? We tried everything from here, and the result is sad face. Now we have all the tools that we need on our attack machine. Why don't we have a mechanism to reach this port? And this is why SSH is so powerful. You can. And so basically what happens is that with SSH, you create a tunnel that will go up to here. I'll try to make that more clear, I guess. And so what we'll do is that we'll send our data here, and it will go out like it's coming from here to go there. Okay, that's what we're gonna try to do with our SSH tunnel. SSH tunnel. Now, the syntax for SSH tunnel, and you can figure this out on your own with the man page. But if you search for tunnel, so searching in man page, you just write slash, and then we'll search in the man page. Search for tunnel, couple words. Maybe it's not super clear. That's not the type. So SSH has basically a lot of different types of tunnel. It's not helping. I know the name of the option. I'm gonna like reverse figure it out. Okay, so dash capital L. But so it's here, if you look at the man page, it says specifies that connection to the given TCP port or Linux socket on the client host are to be forwarded to the given host and port. So what's interesting is that an SSH tunnel doesn't only allow you to do port here, which is already in itself very interesting, right? You're tunneling securely, getting out and poking the local system, but it allows you to go from the system you are connecting to another system only available from that system. So capital L, and then you have port, host, and host port. This is what we're gonna build. So port is the port on the client, host is the host after the original SSH connection. In our case, this is sysadmin service. So our original SSH is to pivot box, but from there, our tunnel, we want it to be destined to sysadmin service at the remote end. And then there's host port. So if host is sysadmin service, host port is 5555. And so let's try it. Okay, we had our previous command. We still need the key because we're still authenticated to that system. We're just adding another feature on top of it. So dash capital L port. Our port is local. Basically, we invent it, right? As long as we remember what value we put there, this is local. This is for us for later. Because although we're setting that tunnel, it's not giving us the flag instantly. We still need to query that service. But instead of doing it from the target system, we will do it from our own system. It's all going to make sense very soon. But this port, we can figure it out on our own. A really good value is 1, 2, 3, 4, 5. Doesn't matter, to be honest. Okay, then it was host. Host, we'll put sysadmin service because pivot box knows what that means. It translates to 172.1.0.8. And then 5555. So what's weird about the first time you do an SSH tunnel is that you think that the SSH tunnel is so important that it's going to change the behavior of SSH from the command line perspective, but it doesn't. So you press enter and you still have your shell. But what you don't know, or what is not obvious, is that the tunnel was connected at the same time. So you do have your command interpreter, but the tunnel was created. So if we look at our local machine, so I'm opening a new command line on my local machine, and you do a netstat to look at what our open service is, and let's grep 1, 2, 3, 4, 5. And so the flag that I'm using, the P flag, is to show the process associated with a socket. This requires root. This is why I added sudo and I need to type my password. But so, unfortunate positioning of Zoom. Okay, let's just run it another time. All right. So what you can see from this is that on my local system, now that I did the tunnel, I have something on port 1, 2, 3, 4, 5 that is listening, and it's SSH. So SSH created that tunnel for me. Now I want to solve the flag. I want to find the flag. What was I requested to do? I was requested to poke the service. So that's what I want to do. But now, what's the thing that let's go back to our diagram. So now that I have this tunnel and I'm here, how can I query it? I can query it by accessing my local system on port 1, 2, 3, 4, 5. So if I drop a packet destined to localhost 1, 2, 3, 4, 5, this will magically go to sysadmin service port 5555. Let's do this. So I'm going to use ncat because it's the superior alternative to nc, which is netcat, which is the old, venerable at this point, TCP Swiss Army knife. So I'm going to ncat 127.0.0.1, which is localhost, and I'm going to do the port 1, 2, 3, 4, 5. This will magically enter the tunnel, go through pivot box encrypted by SSH, get out
at the other side of pivot box and go to port 5555, and I'll get the flag. And this is what happened. Congratulations, you pivoted. So imagine all the firewall bypass capabilities that you have once you master SSH tunnels. So it's incredible. You can do so much shadow IT with SSH tunnels. And there's even a concept in SSH where it's called proxy command, where you can SSH into a box behind an SSH tunnel. SSH is very, very powerful. And so let's try to put that password in. And we got it. So let's look at how we're doing. This is, again, very hard to know where everyone is at, right? So I'm taking it really slow, maybe too slow for some of you, maybe too fast for others, right? Trying to do my best, trying to be respectful of everyone's time. So we got 6 solved for the first one, which is very good. And then the last one, we're like, oh, 5 solves. Okay, so we're doing great. All right. So the pivot box service is useful. So keep it close, because once you do XSS attack on other people on the internet, you need them to be able to exfiltrate their secret to a server somewhere. Their browser will want to talk to something, and you need something to listen there. So don't forget that system. We're going to use it for the last challenge of the web track. Now let's look at the web track. Or you know what? Since it's a beginning of a new track, we can take a couple minutes. I'll ask the people on site how they feel. Be right back. Est-ce que ça va? Est-ce que c'est bon? On avance? On fait le web? On est prêt? Le web, c'est quand même assez facile. Là, ça, c'est le principe de base. Après, dans la vraie vie, là, on va du coup dans le tonal. On va ça pour être 40. Elle va être facile. Intéressant, mais important, c'est que d'abord, vous allez après ça, on va aller voir attendre de aller sur Google, ça va avoir le concept de faire ouais.
Moi. OK. Bienvenue. Content de te voir. Là, tu as manqué la track 6 admin, mais tu arrives au bon moment parce que tu arrives dans la track web. Donc, pas de connaissances préalables. Le premier challenge de XSS a besoin de peut-être t'aider parce que dans le premier, on a gagné accès au savoir. Oh, sorry. Okay, so you're the first because everyone was starting. I was. Okay, so for the last have access to. All right. So for the web, for the web one, the first one is a true classic of all CTFs that are easy to have access to, and it's use the source. So we're gonna open it, and then what we have is a web page, and we're like, well, I don't know, admin, login failed. User, login failed. Okay, I don't know. What can I do? I can try to look at the source. And if I do this, what do I have? I have, oh. Okay, use the source. Not even using my own advice. All right, so, you know, web pages have HTML code, and that code is all open. No matter how complicated it can be to look at it nowadays, it's still all there, right? It's still instructions given to the browser that are readily available. Merci beaucoup. So in that code, there can be comments. There often is comments. So when you see an advice or a joke around using the source, pas de power. Then it's just look at the source, and sometimes it can be really misleading. Like, for example, a classic of just a twist on that use the source trick is you put 1,000 empty lines, and then the password or the flag is there, right? So if there's 1,000 empty lines, you don't see it in the first screen. You see nothing. But then you realize, oh, there is a scroll bar. And then you scroll at the bottom and you have your flag. So, you know, baby steps. But so it says, if needed, support account is support welcome to. So we're going to do support welcome to login. Hey, hidden account activated. Here's your flag. Now, it's really simple, right? It's 101, but the reason why it needs to be explained is that sometimes there's a hint in the source, and then you're told you're hinted towards the right direction. So it's always something to look at. And a lot of other places where people will hide hints include robots.txt and stuff like that. Common HTTP stuff hidden behind web servers. So we got this. All right. So to view the source, you can use I think Zoom is messing up with my. All right. So you can use the view source like this, Control U, but the inspect mode is pretty powerful, and it's something we're gonna use more and more as we go through the web track. So inspect mode has a source component, but with a nice navigation mechanism. You can, and then there's the network where you'll see queries from your browser.
So it's all good stuff. Oh, and you can see that I'm using like a preset to simulate a phone. Okay. All right. So first one, quite easy. View source. You have a clear text, username, password. You can get in. Now let's move on to the SQL. Okay. So SQL, what's going on here? I'm going to do test, right? Search for test. Now this is a made up challenge, right? But what is key in understanding SQL injection is that it goes into a database, and SQL is a programming language. So it goes in a something that is a programming language. So it must be syntactically accurate, and you must think like the programmer. So now to help us understand all this, we show the query in this challenge. So basically, when I wrote test in the search here, what happened is that there was a select star from items where name, like, and then test is there. So we can say, oh, okay, so this is where it's going. All right, I imagine that the flag will be in the table that it's querying already. So I'm gonna try to look for a flag. So someone in the system is messing with me. In that database, there is already an item in the items table that has name flag, but the description is nice try. So someone's messing with me, right? But this was not SQL injection. So what is SQL injection? Is when you're trying to mess up that query. So what defines the boundaries of tokens in an SQL statement? In this case are double quotes. So if the person who programmed this web page didn't account that I can put double quotes, then he has a problem, right? So I'm gonna try putting in double quotes. Oh, something fucked up. Now, why did the page broke? Let's think about it. Well, let's replace in our head flag with a double quote. So what we have is like, double quote, percent, double quote, percent, double quote. This is invalid syntax. So of course the SQL lexer, when it arrives in the SQL engine, it says, this is not SQL, man. Fuck you, I blew up. And PHP was made to fail. In this case, I'm not ignoring errors. I am bubbling up errors. So let's start by thinking, okay, but how can we make it legit? Okay, so let's put double quote and then put or, and then let's put name. I'm trying to think. Okay, I don't want to spoil the flag too fast, right? So I'm gonna put like ABC, and then or name, and then I'm gonna finish, because the thing is we need to finish that double quote correctly for it to pass, right? So or name equals, and then I'm gonna do ABC, and then leave it like that, right? So what does this look like? So this works, and let's look at why. It works, but we don't get the flag, right? So it says like, double quote, percent ABC, double quote, or name equal, double quote, ABC, percent, double quote. So it's syntactically valid, but it doesn't yield the result that we're looking for. Now, what would? All right, so the where clause is using Boolean logic, okay? So if we can do or, we can do or true. So it's like where name like false or true. Then if it's true, all rows are gonna be evaluated to true, which means that I will get in my result set all rows. So we can do then, okay, let's do a true statement. So we're gonna close that bracket here, and we're gonna do or, and then the classic true statement that you see in every joke online about SQL injection is or 1 equals 1, okay? But this could be simplified to 1. 1 is a positive value, is a true value when evaluated. So it's always, you guys should come up front. It's very loud. You'll not hear anything. One room here, one room, or you can sit together as you want. But so we'll do the 1 equals 1 because, you know, it's the XKCD joke and stuff. But people should do or 1. And I'm explaining you why. 1 equals 1 is like in every fucking filter out there, right? So if you do or 1, it's harder to filter 1 because it could be a legit value input by a customer. Yes. Come on. There are many ways to bypass that challenge. Many ways. So I'm gonna show you one, but now I'm teaching SQL injection. So we'll do the legit first. But then there's one, you're close. Ça doit pas marcher, semicolon. Semicolon probably doesn't work, but there's one simpler that works. And you have everything. Semicolon works? Okay. No, but I don't want to spoil it, man. No, we'll get there. We'll get there. But so, okay, let's do or 1 equal 1. But then I'm too in a hurry. Like I'm too excited. I do or 1 equal 1. And I'll do search right away. Ah, shit, error. Why is that? Now, since we have the query, it's easy for us to answer that. But imagine when you're doing CTF, you don't have the query output in your face. So oftentimes you need to go in an actual SQL engine and try the stuff, right? And we could do that if we want. I don't know how. I think I'm slow, so I won't do this. But you have SQLite on your system where you can do that. But so one of the important tricks is to know how to comment in SQL. So if you comment the rest of the sentence, you don't have you can avoid to having it syntactically valid. So comment in MySQL and many SQL databases is 2- followed by a space. So now I'm doing closing the first part of the where clause, saying or true value, and then the rest we ignore. It's a comment for programmers, you know. Let's try that. And boom, here we go. We look at the like. So it's like everything or 1 equal 1, and the rest is ignored by the SQL database, the SQL engine. And so now we have like, congratulations, and then flag equals, and we realize that we had a little bit of trolling material in there. Like if you put just 1 equal 1, you are onto something. But so our flag is here. Now, let's get creative, as our friend just suggested. So I never expected comma, semicolon to work. But so percent sign in this in the like clause is a wild card. It's like star in most things. I don't know, the old farts who designed SQL decided back then that it was a different character. It's not star. But so here's the behavior, and I'm getting back at you regarding the semicolon because I don't understand what's going on. But if we do percent sign and we search, it's gonna work, right? But you see it here. It's here. It's showing up. So you put in percent in search. When you look at the query, the person that you've written is in the query. And basically, why does it work? It's because this query is, I want anything, anything, anything. And it works, right? Now, the behavior of semicolon troubles me. And I'll show you why. Because it's not showing in the query. So it's probably not the SQL engine that gobbles it, it's probably something that PHP is doing. Yeah, you can do that, but it would show. We would see it. Because what is displayed is what is sent to the SQL engine. So I don't know what's going on, but it works. You know what? Let's take a look at the source. Maybe it is showing. No, it's not. Yes. It could be, but I would need to be convinced. I'm not 100% on this one, and I think like right now I think about it. I think there's a bug in this challenge. If I put nothing, is there an error? Ah, I validated the case where there is nothing, because then let's say that I wouldn't have put this case. The query would be percent Oliver. Yeah, but why is the semicolon isn't in the query, right? Where does it disappear? It still should be string concatenation inside a PHP variable. Okay, so let's look at the inspect. Okay, let's look at this from the inspect console. Let's look at what is sent by the browser when I put a semicolon. Whoops. All right. We are sending payload. We are sending a semicolon. So this is URL encoded as %3b, which it should be URL decoded by PHP, then injected in a variable that is string concatenated. For me, I still can't explain it. I'm still a bit dissatisfied, but I'm sure there's an explanation. But so let's do let's take the F here, right? So if we had the proper F, it will work. So let's do the F and then semicolon. See what it does. Semicolon really disappears. Oh, my G sucks. That's my mistake though. So I tried to use UTF-8 characters, but there is a collation in SQL where similar characters will be interpreted differently. Anyway, we dug deep and you can see how it can be, you know, more complicated. But let's move on with our next one, which is the self-XSS. Any questions on the SQL injection? You can see how once you understand what's happening, it's kind of simple, but it gets complicated when you try to exploit it because most of the challenges will not be the simplest cases. You really need to think like a programmer, basically. All right. Oh, a lot of people solved the self-XSS. That's good. Okay. So what's the difference between what we had before and the self-XSS? Boom. Okay, so we have a search very similar looking to the SQL injection. So we'll do right away or 1 = 1, right? And then, this is not the SQL injection challenge. But what's different here is our output is there in the web page. Now, being able to modify a web page is something that we know and we deal with the web since ages, right? We're really familiar with that. But what's the attack behind that? Well, the attack is if I can inject JavaScript, I can then have your browser do something as a third party. So, okay, I'll do a diagram. So we'll have like the user, the, let's say, attacker, and then the victim, and then the web server. So when we were doing nothing on the internet, it didn't matter XSS. People, I was one like in the 90s downplaying the importance of the vulnerability. Even in early 2000s, I was like, no one gives a shit about XSS. It's like remote code execution or nothing, right? But then, well, the thing is that the relationship between the web server and the victim grew in importance, and a lot of trust is behind it, right? Let's say the victim is Donald Trump and the web server is Twitter. If I can impersonate Donald Trump on Twitter, I am pretty fucking powerful. Not right now anymore, but at some point in the past, I would have been pretty fucking powerful, right? But this is what I would get people to invest in my crypto for sure. So this is basically what XSS is. You are sending a URL. So let's, my diagrams always start elegant and they always become a mess, but you know, you follow along, please. So you send an URL, no matter how, a Twitter DM, an email, whatever. The victim clicks on it. It is in that URL. There is code injected, JavaScript, that will be sent to the web server and interpreted by your browser. And this is another thing weird. It's like and this is called a reflected XSS. So the victim is carrying the payload to the browser. The web server reflects the payload in its page. When it comes back to the victim, there is JavaScript, and the browser is like, JavaScript, fuck yeah, I'm executing this. And so this is the attack. And now we will do a simple case which we call self XSS. So XSS is yourself, XSSing yourself. It's very for demonstration or academic almost purposes. But then the real attack is going to be on the next one, where we are attacking someone who clicks on everything we send his way. Okay. So the first one. So in the first scenario, we're basically attacking ourselves. But what we can see is that we are modifying a web page with input. So this is always the first place you start to dig. Okay, are they doing any filtering? Well, let's find out. Can I do this, right? Oh, look at that. The HTML bracket disappeared, but the thing is bold. This is exactly what I asked. And you can see here that there are bold tags. Well, you might not see, I don't know how small this is, but the bold tags were carried. This is the beginning of something very dangerous. So what if we do put script tag and then some JavaScript? What is going to happen? And this is all valid. So script tag, JavaScript, valid JavaScript, close the script tag. Then let's do the search. Oh my God, it's written hello and it's not written document.write. So what happened? What happened is we actually had the JavaScript executed. We can see that what we have is still the script tag. It's still there, right? The browser, the web server reflected all of what I've written to the browser. The browser, when it saw that line, it did its job. It said, oh, this is script. I'm executing JavaScript now. This is what I do. And then boom, hello is printed. And then the rest of the page is rendered. Okay, let's go back to the challenge description now, because we pretty much have XSS. Challenge description says your payload must absolutely contain alert 1. And this is just a cheat hack so that the web server could send you the flag. It's not really important, but let's do it. So script alert 1 script. We got the alert. So as the page was rendered, it stumbled upon the place. So the thing is not even available in the inspect console, but we did get the alert. Then let's do OK. And then search for nothing, because it was just pure JavaScript. Nothing was output. It was all hidden by the browser interpreting code. But you have the flag here, right? Congratulations, you XSS'd yourself. And we have the flag. Again, super fake to understand. Next one is the real one. And you'll see this step up a bit. It's probably the hardest challenge of CTF 101 is the next one. And it's because XSS are complicated to perform. These are complicated attacks to do. All right. So XSS Larry. I should have called him XSS Trump now with the example I made earlier. But so we have the challenge. So similar page. Actually, I think it's the same page. So you can submit URLs for Larry to visit here. So basically, Larry is a very enthusiastic page visitor. So whenever you send him stuff, he will visit. So let's have him visit, I don't know, google.com. So here behind the talking, it was written that Larry visited the page. So we have no output. We don't know. Larry doesn't reply to us. He's just an enthusiastic person browsing Reddit. So we have no output. So how are we going to steal Larry's secret? Well, it's tough, right? Let's continue reading the description. Our goal is to steal Larry's browser cookies for the ctf101.nsec.io domain. So a browser will not send unrelated cookies to unrelated web servers. So we will need to find an XSS under that namespace, that domain, and have him execute JavaScript that will send his secret to us, a third party. It's getting pretty fucking complicated. For this task, you will need an accessible web server. You can use PivotBot. And this is where it brings back to the SSH track, where we have SSH to a server that is reachable from that victim. So the sysadmin SSH system, the sysadmin SSH system is shared, okay? We're all on it together. So we will all need to use different ports. So I'm going to use a port. You're going to have to use a different one because you will not be able to start a web server on the same port. It's important to understand. So I'm going to go there and run a server. Python 3-m http.server. And I'm going to pick 1, 2, 3, 4, 5. Okay, it started, which means that it's running, which is great. Now, I want to confirm first, before getting into any XSS, any complicated payload, what you want to do is confirm that Larry, the clicker, can go to that web server. I want to see him browse. I want to see him work. So in the challenge description, we were told sysadmin.-ssh is going to resolve to the good host. But I use a different port. So I'm going to use that port here. I'm going to send this to Larry the clicker. 1, 2, 3, 4, 5. Larry, click Larry. Let's go. Oh, I got a request. I have a get /HTTP 1.1. Didn't have that before. So Larry visited. Larry delivered. He clicked on that link. Now, I'm not stealing any of his secret here. I need to figure a way to steal his fucking secret. That's what I'm after. And I need to do this under the CTF 101 domain. Luckily, I have a web page that is vulnerable to reflected cross-site scripting. So what I'm going to do is I'm going to attack myself now, but then eventually I'll build the perfect URL in order to be able to attack Larry. Okay? So the secret are going to be in a cookie. One way of having access to a cookie is the document.cookie. So let's do this on myself. Nothing. It could be normal. At the same time, I think I forgot to write it. Maybe that's the problem. Document.write document.cookie. You can see that I've done this before, right? All right. Still nothing. Well, maybe I don't have cookies. Do I have cookies? It might not be one that is available for JavaScript. So you can have cookies that are HTTP only and that the JavaScript context cannot access it. So it might not be the best test. Let's do this. Confirm that we still have injection. We still have injection. Okay. So instead of doing the cookie, we're gonna do a query. Yeah, let's now that's a bit too much. Oh no, that's not bad actually. Okay, so we're gonna just decomplexify this a little bit. Yeah. So okay, no. Okay, no, I'm sorry. I'm gonna start with something simpler. So I need to exfiltrate information to a third party. To do so, there are various mechanisms, but one classic is the image tag in HTML. You can basically request an image from everywhere. There's no notion of third-party security when it regards to pulling resources like images. So we're gonna pull an image from the SSH service that I used before. So sysadmin-ssh. I should use double quotes. I'm not sure double quotes if they're gonna work. Let's try that. Whoops, double quotes are not working. Let's use single quotes. All right. So you can see that my browser is still working. And then I have a broken image. So what happens in here is I do have the HTTP column / sysadmin ssh a.gif. Okay. So this works. Now, I don't have access to sysadmin-ssh. This is not a public IP. So, and my web server, unfortunately, is in the CTF 101 Docker environment. But will this work on the victim? We can try. And this challenge is helpful because helpful in the sense to learn, because I reflect the query in the URL, so I can you have only to copy and paste the content of the URL and send it to Larry. So it's kind of making life easier for you here. So let's do that. So Larry visited this. We should get a request. Oh, you know what? No, I forgot the port. So 1, 2, 3, 4, 5 in my case. Your case is different, right? So let's search and then copy and then visit. Just before, so I put a couple of new carriage returns so that it's obvious that it's a new request. Oh, so we did get the get, right? So when I put an image tag in this via injection, via XSS, and when Larry clicks on that link, his browser is trying to pull that image. Now I just need to add the cookie to it. And this is where you need to learn JavaScript. So the double quote limitation is an important one. You almost always need to put double quotes, especially if you nest JavaScript and HTML. So because of that limitation, we're going to do everything in pure JavaScript. It's just simpler. But so I'm jumping a little bit forward here, but I'm going to explain everything line by line, and you'll follow. You'll see no worries there. So the only complexity that I'm adding now is that I'm doing this pure JavaScript, and I'm adding the fact that it's going to be dynamically created in order to avoid double quotes. So what we have here is I'm using JavaScript to create an image tag, okay? That image tag, I'm assigning it this URL. So the URL and so this URL is http:/sysadmin. Oh, I almost forgot my custom port. Column 1, 2, 3, 4, 5. So my web server that I control. A.gif. A.gif, no one gives a shit what is the name. It could already be like just the /. Then to that, I'm appending document.cookie semicolon. So this is ending. So the image in the JavaScript memory, this image tag has this URL. But if it doesn't exist on the DOM, it will never be queried, that image. So that last section is to add it to the DOM, the document object model, so that the browser will be, oh, there's an image. I need to go fetch it because I want to display it to the user. So, and then image, which is the name of the variable that we assigned at the beginning, right? So with this, we should have a pretty good recipe. I see one risk. One risk here is that my cookie is not URL encoded. So it could fail because if there's a value that is not legal in URLs, something, either Larry when he clicks on it or something in the chain is gonna fail. But we're gonna execute it like that and see. So we know in advance that for us, all we're gonna have is a broken image because sysadmin-ssh is not reachable from my computer. So let's do that. I'm gonna add a little like column A equals so that it becomes a parameter and not appended at the end of the .gif or GIF. I don't know which club you're in. So, okay. So this is a complicated payload that I'm going to lose. So I'm going to write it down here. I'm going to create a web and then do a readme and then readme and then put this here. All right. Okay. Search. As expected, browser waiting. It's going to get broken image and it's not visible. Now, let's send this to Larry and see. We're going to do a couple carriage return so we see if it's new or not. Let's do this. Oh, no need for URL encoding. We have the flag. So let's recap. What happened? What the fuck is this fucking complex shit that is called an XSS? It is we, the attacker, sent to Donald Trump a URL which contained, and if you look at the URL that we sent, right? It contains a search with characters that are HTML characters that should be filtered or escaped or whatever. That is not escaped or filtered or whatever. That is reflected by the web server. So this victim's browser sending that query is processed by the web server. The web server sends that back as a web page, which has the angle brackets and stuff like that that was unescaped. And this goes to the victim. And the victim is like, oh, it's JavaScript and it's coming from a web server I trust. Let's execute it. And then part of that JavaScript is injecting an image in the DOM and saying there is something at a.gif on our attacker's machine, which is not in the diagram. And then this is the browsers that is going there. And then we are hiding the secret in the query. We're saying, I want an image, but this image has this URL, which have the flag in it. It's pretty fucking cool. XSS. And this is a simple one. Like the ones at NorthSec, the guys are just completely crazy. Like, I don't even understand them anymore. There's like, oh, I found a bug in this, and if you do this, and then. So, a twist on XSS is, so we saw the reflected style, but a twist on it is the stored XSS. So, stored XSS is basically one that goes into the database, and then that when you view a web page, it's sent back to you. So a stored XSS is very dangerous and can be wormable. For example, if MySpace, there's a stored XSS in it and you write to a forum post and you trigger an XSS, then everyone visiting that forum post can execute that JavaScript. And if part of that JavaScript payload, you are posting another post on that forum with the payload, then it's just spreading to everyone. It just becomes crazy. All right, so the hardcore shit is behind us. We're back with encoding, which is our forensics one-on-one. So there are many flavors and types of forensics challenges in CTFs. A lot of them are fairly well, I would say easy. It's not true. Some as you know, everything complexity gets in. And I remember at DEF CON Quals where we had like pieces of a RAID array, and you had to rebuild the RAID array using those pieces and then mount it, and you had to hunt basically the file system structure and reconstruct it. It was very complicated. But so a lot of it has to do with having the eye for something, right? Having seen stuff before, or having the idea of, oh, this sounds like a pointer or encoded or something. So now, this stuff, does anyone have any idea what this is? Like, what is this encoded with? Base 64, correct. So we're gonna learn our favorite tool for those types of stuff. It's from the UK Secret Service. It's called Cyber Chef. It's basically a Swiss Army knife for encoding and escaping and crypto. And so it has a from base 64 recipe. So at the top, you put in the crypto. At the bottom, you get the result. And so here we can say that the flag is here. So let's read it out loud. In this field, you should recognize basic encoding techniques just by looking at them. Congrats, because it looks like you just did so. Here is your flag. So basically, just base 64 decoding here. And we are correct. All right, now we have a document. And in that document, we'll have two flags. Let's look at it. This I used to teach cybersecurity at ETS University nearby, and so this is an old class summary that I use for that challenge. So okay, what are the things? And these CTF challenges, why is this included in the 101? It's because I was very salty about not succeeding doing a challenge one day. And these are two techniques that I didn't succeed at first. And I was like, it's so fucking stupid that I need to teach that to everyone so that they don't fall victim of my stupidity back then. And so, how can you hide stuff in a document? Well, one way, using encryption and stuff legit, yeah. But let's think Secret Service, like hiding in plain sight type stuff, right? And so a thing should draw our attention, but it's normal that it doesn't. But yeah, it's kind of stag if you want. But so what you can do is you can so a Word document is super flexible, right? It allows you to have all sorts of you can put white on white, basically. You can put, you know, tiny fonts and shit like that. So one trick is to copy that, paste all that stuff into a dumbass text editor, and then search in it. And we know, you know, we're in a CTF. What are we gonna search for? We're gonna search for flag, right? Boom. I got a flag at the end, at the bottom end that you probably don't see. Sorry about that. Oops. Somehow dragged zoom. At the bottom end, there's something that matched flag. Okay. Now, what we're gonna do is we're gonna go back to the document, select that text, and we see that there is text there. And then we're gonna make it darker. Here we go. So, ça marche, c'est nice.
Un, deux. Yeah! On a du son. Je pense que Olivier, tu vas pouvoir parler moins fort.
Mais j'ai du monde sur le stream, ouais, je sais pas. All right. T'as-tu un petit pied? Ça serait vraiment cool. Ouais, ça va être long à setuper. All right. Ça veut dire que je vais être capable d'animer le Hacker Jeopardy sans avoir plus de gorge. Okay. So basically one trick is white on white type stuff. Let's paste it in the thing and move on to the next one. Oops. All right, we succeeded. On a réussi. So the next one. So it says the flag is in French, but it still starts with flag dash. All right. Okay, let's go back to the document. Gonna cheat a little here, but this is the one that I never succeeded in a previous CTF, and I was really salty when I learned the answer. And so one hint is the spell check. So why is spell check clear? Okay, here we have names of people. Okay, spell check doesn't clear. It's not too bad. But why do we have at the top all sorts of mistakes in words that looks like they should pass? So let's paste specifically this part in a console. All right, so if we look at it in text, what we can see is some weird things, right? So the first word that is buggy is informatique, and then is fine, is not fine. And so if we look in our console, we see F, capital F, we see capital L, we see capital A, and then capital J, G, capital G. This is basically flag, right? So it's hidden there somewhere, somehow. Let's put it in red. It's not just red. It's like tiny. So let's put it in, 60. So F, L, A, G. At this point, you guys should do it manually. But this is CTF 101. Another lesson I want you guys to realize is that the difference between a regular challenge and a challenging challenge is that they will take something simple, like, for example, solving a CAPTCHA, and they will ask you to do it 5,000 times, which means that you should not do it by hand, which means that you need to code something. Learning to script is a key part of solving CTF problems. There's a whole subcategory of these that are usually called programming or programming related. So we're gonna do this, but programmatically. Now have in mind that this one, in this case here, you should do it by hand. I'm gonna lose more time programming it, but still the lessons are important. And you'll see also the way I advise people to operate. Baby steps, not doing everything all at once, building towards the solution. Let's do that. So I'm assigning the string to a variable. Let's remove where, like here, the words are normal. So we're gonna substring this to just that portion, and so yeah, like here. Okay. All right. Now imagine that this problem is way bigger. Imagine we have thousands of characters, and it's like a binary encoded inside a document, and so we need to do this 1,000 times, so we cannot scale it. But let's do it programmatically. So now what I want to do first is I want all words in separate tokens, and I want the last character of every word. All right, so I split into words. Now last character. Let's do a test. Oh, no. So now I realize that this is at the bottom and I need to put it higher. So I'm gonna have to do something a bit weird, but bear with me. All right, if this is good, right? You all can see at the back. Yeah, okay, perfect. Let's move on. So in C, I have one. That's not a good choice. So in C, I put one word as a test. Now I want a last character. What's the syntax? Oh yeah, I got it. All right, let's go back to our list then. Okay, so this is a list comprehension, a very powerful Python concept. I advise everyone who's programming semi-regularly to really look into these. They are very powerful, as I said. Now we see that we have the last character, but there is some garbage. So we have commas and stuff. So there's a problem with the way we're doing things. Why is that? Oh, because when we split, we kept the commas. So let's just get rid of them somewhere before we do our last character assignment. Whoop. Okay, so not perfect, but pretty close. I think we're gonna be able to figure out that last buggy character. But so what I just did is basically this string, or the string, I replace comma with nothing, column with nothing, dot with nothing, and then I extract the last character inside the list comprehension. So now let's join that back together because I'm too lazy. I want to cut and paste. So the string object in Python has a join attribute, which takes a list and you select on what you want to join. So I join with nothing. So I have this. So I told before it was written that the flag was in French. So this is flag with a T. It's a mistake. Le fl du fin observateur. So it's le flag du fin observateur, and the FL part we can figure out from the string by looking at it. We have domaine and then a, and then a carriage return, and then a 0 and column. So I don't know how the document got like that, but I mean, we can figure it out and solve it. So let's go back, put that in, fix the little thingies that are offset, flag, and then here it's also flag. So le flag du fin observateur. And here we go, we are correct. All right, we're almost close. 2 challenge left, but they cracked me at the end. All right, network. Well, pretty much all CTFs have PCAPs. I don't know why, it's a religion for security people, PCAPs, and you know what, I love them. I guilty as charged. So PCAPs are opened by Wireshark. We're gonna do things a bit inefficiently here because you'll learn some stuff while we do so. So I clicked on something, I fucked it up. Okay, what we have is a very small PCAP with a sequence of ping and reply, and we can look at them like that. And the problem with PCAPs is that it can go in all sorts of directions, right? There's so much data. If you start, you could look at timestamp. If you have TCP, you could look at sequence number. You could look at all sorts of stuff. You can get drowned in noise. But now ping is pretty simple. And usually, well, people who looked at PCAPs before know the ping pattern for Linux and Windows by heart. It's like a crescendo, and it used to be to detect error correction, not error correction, error on the media. So if some bits were corrupted, you would see it in the ping reply. And so ping is comparing what it sends, what you send it, and what it sends back what you send it. So here are data packet for someone experienced in networking. You would see that it's not regular. Someone is using a different data package in ping, and this is allowed by the protocol, but no one does that. So if we scroll down and look at here the data section, okay, we will figure out what the solution is pretty easily. So F L A G dash N E. So easy solve would be to write this down and then submit the flag. But we want to learn something else. We're gonna do it the complicated way. So what is a good way to scale Wireshark analysis is to use T-Shark. So T-Shark is the sister tool that is on the command line. So what I'm gonna do now is I'm gonna find a way to extract the data out of the PCAP, just the data section. All right, so if we use a -R for read and then send the PCAP to T-Shark, what we get is kind of a nice text-based summary of pretty much the information we have in Wireshark's upper pane, which in itself is not what we're looking for. So the key component of T-Shark, if you want to scale it and automate it, is the -T fields. This puts T-Shark in a mode of field extraction. Now, the fields that you want to extract, you will add them individually, adding -E and the name of the field. So what we're going to do is T fields -E, and then we're going to add names of the field. How can you know what's the name of the field, you ask? Well, let me tell you that Wireshark is very helpful because there is a feature when you right click that is called prepare filter. So if you do prepare filter and selected or not selected, doesn't matter. What you have is that it will create a query for you at the top. So this allows us to learn. So what is, let's say, ICMP checksum? What is the name of that field? Let's do prepare filter selected. We know that it's ICMP dash checksum. Pretty convenient because we didn't have to look through pages and pages of fucking fields name. So did I just swear on the stream? I'm sorry. And here, sorry. So we want data. So let's select data. And then I'm gonna do all of what I just mentioned after I drop the mic. Okay, so we have our data here. Interesting. Everything is separated by one line. It's very neat. But now I need to scale that up. Another thing I want you guys to learn. IPython or interactive Python console is powerful. IPython notebook is like powerful and documentation at the same time. If you guys never use this stuff, you should learn it. And it's called Jupyter Notebooks now. But we're gonna use a Jupyter Notebook to solve that challenge. So I don't know if you know about this, but Jupyter Notebook's pretty cool. So we can do like, you know, okay, it's markdown. I'm gonna write, I never do this, but for the demonstration purposes, I will. I'm gonna document what I'm doing. So you can embed markdown directly into it. But the other cool thing is, so this is Python basically, okay? But the IPython kernel allows you to mix with command line. So let's do that. The syntax for it is exclamation mark. So exclamation mark, everything that comes after is executed in a shell, okay? And you can assign it to Python variables. This is sick, right? Because shell script usually are a fucking nightmare to maintain because no one documents them properly. Now you can mix them with code and just focus on the interesting bit and have markdown for your documentation around. It's pretty neat. So now we have this. And we know that this as a list in Python will be easy to process. So now in the next couple of steps, what I want to do is, since it's 464646, 4C, 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 and stuff like that, I'm gonna grab just the last two characters of every line, but not every line necessarily, every line out of two. So we're gonna do this together. So as I was saying, I'm going baby steps, right? So I figured out that extracting the last two character is to use dash -2 column with anything. And this is in Python to say, start from the last, go back 2 characters, and adding the column means, but I want to get the rest of the string up till the end. So this way you get the last 2 character. Now I did this for one item because I wanted to confirm that it works. But if we do again a list comprehension, you can do that on all lines. So let's do that. Okay, now I have it in the way I was interested in having, but now I still have it duplicated. Is there a shortcut to get rid of every one out of two in Python? There is, and luckily I Googled this before being here, so for me it will look easy, but it's not quite easy. But actually lists take 3 parameters, beginning, and then kind of this iterator, fancy iterator. So we're gonna do just that in order to extract 1 out of 2 fields in the data list. Okay, we're getting closer to a solution. So we clean that up. So now what we have is X for the characters that we want to do. Now let's just run on top of this CHR so that we get the character value associated with this X. And the programmers in the room will know that this is not gonna work, but I'm still doing it. And the reason I say that is because I recognize the Boston Tea Party people at the back, and I know that they're gonna laugh about my programming and my stuff here. I'm teaching CTF 101, guys. Okay, so the reason it fails is because the character I extracted were out of a console. So it will fail because it's considered text. So now I need to cast this somehow into an integer because CHR expect integers. So hint in Python 3, in the hint method, they added a very nice convenience function where you can set the base. So you basically pass the string to the int and you say it's base 16. And so it will interpret it as the proper integer in the proper base. And then you pass CHR into it. And then we're gonna do the trick we did last time. We're gonna join that list on an empty string, which will assemble it for us, and then we'll have the flag. So again, doing this from the PCAP would have been faster, but now you've learned about IPython notebook, the fact that it's kind of documenting itself, and the fact that you have the recipe for later. So it's a pretty neat tool chain that I like to use a lot in work and in CTFs. There was a Monterey hack yesterday evening about embedding Radar, the reverse engineering tool, inside IPython. So you could have like interactive, easy to share, web-based reverse engineering toolkit inside of Jupyter Notebook, which is pretty sick when you think about it. Okay, moving on to Crack Me. So the goal of that Crack Me, okay, is so that you're not scared. And we're not gonna understand all of what we're gonna look at now, okay? But actually, we're gonna understand very little of what we're gonna look at. But the idea is that we're gonna open tools that are scary, and that the first time I opened them, I closed them. I was like, I think I infected my computer, right? It's so weird, full of zeros and ones and shit. And the guys doing the reverse engineering are so better than me that I'm not gonna ever do that. It's too complicated. But that's not true. You can take it bite-size, pun intended, I guess, or not. But you can take it, you know, little by little. And sometimes the challenges are quite easy. it's just the way to approach it, not being scared and taking, baby steps. And this one is a particularly easy one. You can do it in static, you can do it in dynamic. It's quite easy to approach, actually. Let's do it. So first, we're going to look at it statically. So static analysis means without executing anything. And so for that, we're going to use Ghidra. I used to joke about the NSA having access of my computer, but now they're friends. I forgot Snowden. I forgot them. Bad joke. Is it too soon? I don't know. But Snowden in Russia, Okay, it complains. I don't know why. I know it doesn't exist. Give me a break. All right. Don't want that. Okay. So Ghidra wants you to set a project, and you haven't added the binary to it yet, but you open it. It's Java. It takes a while. It's pretty powerful though. And IDA Pro is like $3,000. This is free. So who wants IDA Pro except those that can afford it? Let's go. Let's load that crack me. Okay, nice. And what I like about modern tools like that is that for someone stupid like me, you can go and look at the decompiler. Like, I'm not even a C programmer. It's not true that I will understand the assembly, right? So why is there an error? Okay, so some libraries are not found. It's gonna make me running it complicated. Okay, so now we opened it. Okay, we have access to all that stuff. The important pieces are exported. The calls that the operating system makes to run your code, it needs something to be exported. So the first thing you want to look at when you open a binary like that is the export table, where what stuff that is exported to the operating system. Everything that starts with an underscore, you should ignore, right? And in this specific case, you saw in the browser that there were two files. So there's one that is -hard, and there's one that is regular. So the -hard is stripped. So what does strip mean? It means that to save space in the 70s, they decided that we should remove symbols because the machine doesn't need them. And so it means that there is no human readable strings in the file itself, except if you print stuff and stuff that interacts with the user. But so things like this would not have nice strings that are readable. Instead, it would be just F with an address in the binary. So we're doing the easy version here, but oftentimes you'll have stripped binaries, unfortunately, for the real reverse engineering challenges. Okay, so all of this is exported. So it's more than anticipated, but there's a name that stands out, and it's called main. So we're going to click on main. So now we see the assembly of the main function, but let's take a look at the decompiled. It's better. So now we see, okay, buffer, printf, dramatic. Oh, a function called dramatic. What is dramatic? When I look at it, oh, it's a for loop with a sleep, and then it's writing a put char on something. Can I cast it as something else here? So in char, this is a dot. So it's basically doing a dot for how many times? It's not clear. It's from parameter. All right, it's coming from the main. Let's go back. So it should, oh, dramatic 3. So it will print basically 3 dots separated by sleep, and then x10 is carriage return. So x10, it's decimal, but 10 is carriage return. So you'll see after that a carriage return. Okay. So far, it's safe. Like I could run it if I want to. So that's good. Then compute. Okay, what does compute do? Oh, compute is a lot scarier. There is a bunch of stuff in here, you know, crypto mumbo jumbo. Then there's SHA-1 function here, and then some comparison. Eh. And then it's returning MD. What's MD? MD. Oh, it's a malloc, so it's a buffer. Okay, okay. Compute is scarier. Let's move on. And then, oops. And then it prints the flag, the beginning of the flag, and then raise. What is raise? Well, when you don't know about a function in the C library, you can always use man pages to find what it is. So let's do that. Okay, so the programming API of the C library is in the section 3 of the man page. So you because Raise has other man pages of stuff higher level, you need to specify that you are interested in section 3. So send a signal to the caller. So basically this will send the signal to my process, which means that it can destroy it or fuck it up, right? Which is not what we want. So we have to keep that in mind for later. Then it looks like it's gonna print. So it's printed flag, and then it's about to print. But there's this damn raise at the middle. And then put char, another carriage return. Okay, you know what? I've seen enough. I'm ready to run it. I'm not scared. I'm no longer scared that I'm gonna infect myself. By the way, I don't recommend this doing this in most CTFs. Here, NorthSec is friendly. Nothing will destroy your computer unless it's clearly written in the challenge description. But there are some CTFs out there that have been known to have malware or destructive payloads. So always do this stuff in a VM, usually. So I'm making it executable, and then I'm going to run it. And we're going to look what's going on. Performing intense computation, the dramatic function, and then flag segmentation fault, core dump. Damn it. Okay, there's a raise. So I could then do several things. I could finish to understand statically what's going on and solve it purely in a mathematical fashion. So there is data that is performed in compute, and then this data is printed to the screen, but there's something in between. So I could do this purely statically, and because it's lunch hour soon, I won't do that. Otherwise, we could patch the binary. So we could remove the raise statement and then re-execute it without it. This is involves patching it out. So changing whatever the call is by nup, and it's kind of involved. So I'll show you another way dynamically. But so signals are caught by the processes, and the process have an opportunity to do something with them. By default, most signals will have a process terminate, and a debugger is a layer on top of your process that catches your signal, and in the debugger you can tell it to ignore them. So what we're gonna do is we're gonna run that binary inside the debugger and see what we can do with that signal. So the classic debugger is a GDB, and I happen to have a PwnDBG wrapper around it, so it's a lot more verbose and a lot more reverse engineering oriented. So by default, GDB doesn't have anything about the machine code. You basically usually use GDB along with source code. So because it's an open source operating system, you have source code. But so I advise people who are getting serious into reverse engineering and solving challenges like that, they should install either PwnDBG or Jeff, GEF, or there's another one. There's like 3 that are competing severely right now. They all have pros and cons, but me, I'm lazy. I use PonyBG since a while. Okay, so we're gonna run this. So R, then enter. So it started, and we can see we have the output. And then what did it say? What did it say? Oh, it says program received 6.7 segmentation fault. So basically the raise 3 is a segmentation fault that is sent to the DOS, and the OS sends it back to the process. Now, since I'm in the debugger, this is basically a trap, and it gives me, it plugs the process, shows me the state of the stack. So this is the state of the registers. Then you have the code that is running right now, and then you have the stack. There's a lot. This is a lot, right? We're not going to go through this. It would need basically a CTF 101 on its own. It's a lot to understand. There's a lot of stuff. But so what we need to understand, the easy route, if you want me to say, is that the operating system sent a signal, and in the debugger you have the opportunity to ignore that signal. So this is the dynamic way, lazy way of solving that challenge. And so let's do that. So we're just gonna continue, and then boom, we're getting the printf. So basically the raise instruction, the raise function was ignored, and so we have the thing. But if we remember correctly, we had the flag dash before, and it's the segmentation fault that added the carriage return. So we basically need to append flag dash to what the output that we got. So let's do that. And this concludes nicely CTF 101. And I'm right on time, I think. Maybe I'm too short. I don't know. Was I supposed to be 3 hours or 2 hours? Don't check. I want to finish now. Charter. At 1. Aha. No, but okay. So you guys, do you want me to do it statically? So do you want me to do the crypto by hand and arrive at the same result? I can do that if you want. But if you want to have lunch, you can go and have lunch. It's as you choose. I see no one leaving. I'll feel compelled to do it statically. No. So I will do it like, let's say it's malware. So you don't want to run any of it because they could hide a lot of stuff in the start and everywhere, right? If you don't trust it. So what I'm going to do is I'm going to focus on the compute function. I'm going to reproduce the crypto that they're doing there. I haven't done this in a while, so it might not work. We'll see. And then I'm going to try to do that and see what's the result. Now, this looks like a stack canary because of the FS access CPU thingy. Forgot what it's named. So and it's compared after the function, and if it's not valid, it does a stack check fail. So I'm gonna ignore that part. Now the beginning of what is sent to SHA-1 is local 48. So it starts here. So what I'm gonna do is I'm gonna append all of this together. Do I need to append 14? 14 is the length. Yeah, 14. No, that's not it. Where is 14? Maybe it's appended. Okay, we'll try with and without. So I'm gonna basically just extract all of that hex, and then I'm gonna SHA-1 the thing, and we're gonna see if we arrive at the same result. Okay, so what I did is I started my IPython notebook. I did a really rough proof of concept that I can hash bytes. So the B here means that I'm passing bytes. Now it looks like a string, but soon it's not going to be a string. And then I'm doing a digest on it. So hopefully this will yield to the same end result than what I'm trying to, that what is happening in the crack me. I'm more and more scared that this is not gonna work. Oh, I forgot the column, the quotes. Okay, now this is raw strings. This is gonna be enough. I don't think this is what we expected. Let's compare. B5488. B5488. Okay, so I tried in downwards. I'll try upwards. I don't think it's gonna work. So there's something, and it could be Indianness, and it could be the way that Guidra is presenting the information. I might need to look better, or the way the assembly is, because Guidra is showing me something, but it might not necessarily be. And I forgot. Do I have? I have the source code somewhere. Let's take a look at the source code. That is cheating, by the way. So shouldn't supposed to have the source code, but I don't want to end like that. Okay, so it is a string. So it's a printable thing that we're doing here that Guidra can't figure it out. So okay, let's try to convert it as such. Yeah, you see. So this is interesting, and this is actually a good lesson in challenges like that. So somehow the way the compiler transformed this, and it might be for a lot of different reasons that I don't know. Compiler in themselves are fascinating, but the compiler decided that this is way too inefficient, and it's gonna just use registers to build that string so that you can pass it to the SHA-1 function. But by doing so, it makes them look like this in the disassembly, and then even in assembly, they're basically, you know, raw raw X. And I think they are backwards, and I think this is why it's not working. Like 73, 20, 6F 75, 73, 20, 6F 75. No, it's not. It doesn't make sense. 20 would be space, but oh, ASCII 20, maybe not. Okay. So, sorry. Come on. Hex 20, ASCII 20, decimal 20, mais hex, c'est pas, je sais plus c'est quoi. Mais je sais même pas si c'est printable. Okay, but okay. So, do I have IDA? So we'll look at it in IDA instead, see if it's any different. Compute. All right, the stack strings are here. Aha, here we can actually cast it as a string. Okay. So if we do so, we can see that it's upside down. And again, you know, it's probably the way the machine works. It points to a memory region, and then because SHA-1 expects a buffer, so it's like this buffer starts here and goes here, and it's probably writing to it in reverse. But then once we'll have all of the strings upside down, so there is no way you are ever going to figure this out. Okay, so let's write this in my Python instead. Where is it? Here, one sec. Is there, so capital and then no exclamation, nothing. Okay, let's do that. Whoops, it's not the byte string. I need to add the B here. Let's go. And we got B54. So this looks like we got it, right? Let's do it. And I think since I already submitted, I should have still like already submitted or something. Yeah. Okay, so you have to trust me on that one because it says basically you already submitted it, even if you put the right or the wrong answer. But it is another way of doing it statically. Unfortunately, from Guidera, it is a little bit difficult. The way they cast this into a char is not helping us realize that it's a string. But if we would have realized it was a string, maybe, oh, here it is. Look at it. Look at it. So in the C code, it's bad, but in the assembly view, it's okay. So it's possible without paying $3,000 to do that. And this concludes CTF 101. I'll hang around a little bit and feel free to come and see me if you have any questions. I hope you learned at least a thing or two. This is the objective here. So, and thank you for your participation. Man, à chaque fois que je fais ça, ça chie, là. C'est vraiment tough, là. Tu sais, pour vrai, en dynamique, tu peux noter à la place. Tu sais, au lieu de sauter la fonction, mettons, tu peux la sauter. Bref, en dynamique, tu peux aller écrire la mémoire, changer des 0x90 et un up. C'est bien plus facile avec la binaire. La binaire, je le fais jamais, mais il y a des plugins. Non, attends, j'ai des buts, regarde ça. Des étoiles pour aller comme l'adresse de ton instruction pointer ou time, à savoir si tu sais, ok, c'était l'adresse, tu sais que la fin est là. C'est là aussi que c'est comme ça aussi que tu changes, mettons un if, tu peux prendre le flash. Là, tu avant de l'écrire par sa mémoire, tu changes les flags dans le registre. Tu peux tout passer dans le début aussi. Ouais, ben, c'est le code pour ta mémoire.